Okay, and welcome to another Ginger Mathematician video where I'm going to go through an iGCSE Maths Paper 2 and take one of the more up-to-date ones here. So June 2020, this is version 3. You see this page in front of you. Before you start, make sure you're doing this exam. Otherwise, you want to be revising the exam that you are taking. I know many of you are revising over the weekend for this exam on Tuesday, so I thought I'd take the opportunity to go through a full walkthrough. Before we get started, I'm going to say please like and please subscribe. It does go a long way to helping the channel, and this is how my channel kind of blew up a bit, by doing paper 2 videos. So if you tell me you like it, then I will do it. Right, let's get started straight away. So we'll go straight into question 1. So we're going to write this number to 4 decimal places. So what we do here is we count once, twice, 3 times, 4 times. Okay, and then we decide, okay, we put a line here between the 9 and 9, and then we say, is 9 greater than 5? Oh, yes, it is. So it's going to round upwards, but notice we're going to have to round upwards again. So this will then give us 0.0480. Okay, I mean, think of this as 4,799. How would you round this to 3 places? Well, what you do is go 9 and 9 again, and that will give you 4,800. So think of it in the same way, and then you'll get to the correct answer. For this one, we're going to do it to 3 significant figures instead. So what we do is we do our first significant figure, second significant figure, we count the 0 because it's between 2 numbers, and then we get to our third significant figure, we put a line between the 4 and the 4. We say to ourselves, okay, is 4 5 or greater? Well, it isn't, so we round downwards. So be careful with the answer here. This is not your answer, just 604. We need to add in the placeholders. So we get 60,400. Biggest mistake made is that you don't add these extra zeros in as well. And now we have a nice fraction question. So this is things we've done in year 7 and year 8 and year 9. The first thing we're going to do is going to convert these to improper fractions. So the way we do this is we do 4 times 4 is 16, add on the 1 is equal to 17. So we can rewrite the first fraction in 17 over 4. And then make sure there's a minus here. Again, the mistake that's often made is that you put a plus rather than a minus. Here we're going to do the same thing. So 1 times 6 is equal to 6, plus the 5 is equal to 11 over 6. At this point, we want to find a common denominator. Now, 24 will definitely work, and you can cross multiply, but actually an even easier way of changing this is changing it out of 12. So we say to ourselves, what do we multiply 4 by to get to 12? Well, this would be by 3, so we do the same to the top. 17 times 3 is 51. And here, what do we multiply 6 by to get to 12? This is by 2. 11 times 2 is 22. And now we subtract the 2 fractions from each other. So then we get this, and then 51 minus 22. If I'm in the exam, I've got the time to actually just go through this, old school, by actually going through the minusing very, very carefully, So we get 29 over 12. Okay, but notice the question wants it as a mixed number. So this is only good enough for 2 marks. So we need to convert it back into this kind of number. So how many 12s go into 29? Well, that will be 2, and then remainder 5. So we get 2 and 5 12s. Hopefully you're happy with this if you're doing the extended course. This is knowledge you will be expected to know probably even before you do the iGCSE course. Okay, so this is why I've gone through this a little bit more quickly. Quickly check the answers here. So you can see it's the same thing. Yep, just making sure that you get the full 3 marks here and putting 2 and 5 12ths. That is really important. You want to be getting the first 5 marks out of 40 on the exam. That's an eighth of the paper, that's 12.5%. So you've already got 12.5% in the bag. If you're aiming for one of the lower grades, like a grade C, then essentially, if you get this entire question correct, you've got a third of what you need for a C, which is pretty good going. Okay, let's continue. So question 3, we are simplifying the algebraic expression. So let's just remember that if we're multiplying indices, we add the small numbers. So a squared times a to the power of 5 is equal to a to the power of 7. Notice I'm leaving the bottom alone for the time being. And this operation here is the same as saying this. I'm just using a different symbol for dividing. And whenever we're dividing with indices, we minus these numbers here. So we get a to the power of 7 minus 3, and that will give us our final answer, a to the power of 4, like so. Just checking the mark scheme as we're going along. You get 1 mark for just doing the numerator. So say you get the numerator correct, but the denominator incorrect, you still get 1 method mark. So notice I'm not showing all my working here, but I am showing enough to get the marks. However, in the next question, question 4a, write down the mathematical name of a quadrilateral that has rotational symmetry of order 2, but no lines of symmetry. So this would always be a standard shape. So if you think of our standard shapes, we have, say, a rectangle, trapezium, kite. These are the kind of shapes, parallelogram, rhombus. These are the kind of shapes that they'll be looking for to answer this question. And this is a case of just exploring these. We want no lines of symmetry. So that basically takes this out and this out and this out. So we're left with these. And then we say to ourselves, well, rhombus is essentially a kind of square. So that will have rotational order 4. So the only one this could be is the parallelogram. If you're not sure, draw out a parallelogram. You should be able to turn it and be the same shape twice. So this completes that part, but there's no line of symmetry. The diagonal does not work. Again, try that at home, make a parallelogram and see if it works. So our answer here is parallelogram. You do not lose marks for spelling, but don't worry, just pop down parallelogram and you're fine. And mathematical name of the quadrilateral has exactly 1 line of symmetry. It's already one of these I've already mentioned here. So if you take a kite, which I think in German we call a Drachen, a dragon, I don't quite know why. But you'll notice that a kite only has 1 line of symmetry, so we can write that down. I think isosceles trapezium also works. It does, yeah, so you can use either of those. Again, these are marks you should be getting in the bag, so this is an extra 4 marks here. I'll show you the mark scheme very quickly, but you need to be getting these. Again, if you're looking for the grade C, for example, you've got quite a lot of your grade C just by doing these first 4 questions. Okay, let's continue. This is where we start to get slightly trickier. We have an inequality to solve. So we've got 9 minus 2x is less than or equal to 5 open bracket x plus 6. The way I approach this kind of question, treat it like an equation. Okay, so rule number 1, treat like an equation. And there's one thing we have to be careful of, why it's not like an equation, but we'll come to that if we need to. So first thing we do is we expand out the bracket like so. So we get 9 minus 2x, and keeping that the same. 5 times x is 5x. 5 times plus 6 is plus 30. Now at this point we can solve this in a couple of different ways. I'm going to minus 9 from both sides. I'm going to do it this way to show a point right at the end. So this cancels with this. So we're left with minus 2x is less than or equal to 5x. Notice the x's I can't do anything to. 30 minus 9 is 21. And at this point I'm going to minus 5x from both sides. It's not the only way of doing this question. Now we have to be careful with negative numbers here. So minus 2x minus 5x is minus 7x. Make sure you're happy with that. Less than or equal to. These cancelled. This was the point of the operation. And now we're left with 21. So far we've treated it like an equation, but we have to be careful when we divide by a negative. So at this point we're going to divide by minus 7, which is all normal so far. Okay, so I'm going to write the note here. Divide by a negative, we have to switch the inequality. Okay, that's really important. So when we come to our answer here, this cancels with this. So we're left with single x, which is what we wanted. But now we have to switch. So we have to switch this over. Okay, if you're not sure on this, check out my video series on inequalities. I do go through why this is the case in part 2. And then we get 21 divided by minus 7 is equal to negative 3. So the correct answer here is x is greater than or equal to negative 3. Okay, just checking the mark scheme here. Yeah, you get 2 marks, however. So say you get the wrong inequality, or you put even equals, that happens sometimes, you still get 2 marks out of 3. Okay, so you get the 3rd mark for the precision of greater than or equal to. Let me quickly show you the mark scheme. Here it is. So you can have a look through yourself, pause the video if you want to look through and see where you get those marks. And if you're liking the content that you're watching currently, then please do consider liking and subscribing and sharing with your friends as well. Okay, thank you. Okay, question 6. So a biased four-sided spinner is spun 150 times and we're given a relative frequency table. Okay, this is a term that students often forget what this means. So relative frequency basically means the same as experimental probability. It's another phrase for the same thing. If I wrote it like this, it makes it more straightforward what we have to do. So the relative frequency of a spinner landing on 2 is we take the frequency of landing on 2, which is 63, and then we divide by how many times the spinner is spun, which is 150. And since it's a 1-mark question, I don't think we need to simplify. I'll verify that. Yep, we don't need to simplify, although I think it doesn't simplify anyway. Again, 1-mark question, you don't need to worry too much about working. Obviously 2 or more, then you do. Explain why it's reasonable to use your answer as part A as the probability of this spinner landing on 2. Well, notice we spun this 150 times, so we've got a large sample size. They often ask a question like this on iGCSE. If this was only like 20 times, for example, it wouldn't be such a reliable probability. So all we need to do here is just write large sample size or spun many times or something along those lines. Okay, at this point, we've got the spinner is then spun 3,000 times. That's many spins. I wouldn't recommend this at home. And then find the expected number of times that the spinner lands on 2. So expected 2, use this notation a lot at IB. The way we do this is we take our previous probability, so 63 over 150, and then we multiply it by the number of times that we spin. So what they've done with this question is they've integrated a bit of working with fractions here as well, because we actually have to now work this out without a calculator. Now, if I was to ask you this question, so say 1 over 150 times 300, you would probably see at this point that this goes into 300 twice, and this would cancel down to 2. So using the same idea, instead of 300, we have 3,000. So all we need to do is add an extra 0 on. So 150 goes into 3,000 20 times. This will make your life a lot easier to solve this. So essentially what they want us to do here is work out this particular calculation, which is 63 times 20. The way I would do this, I would rewrite this as 630 times 2. We can do this with multiplication. It's commutative. You can move the 0 around, so to speak. And then all we have to do is double this to give us our answer. So if I was in the exam, I would do this old school. I would actually write this out. 0 times 2 is 0, 3 times 2 is 6, 6 times 2 is 12. And I get to my answer of 1,260. Okay, I'm not doing anything too clever. I'm just taking my time and going through this nice and logically. And you do have 45 minutes for this paper, which I think is fair more than anything else. Okay, that's a sip of coffee. Let's carry on. So we've got question 6 there. Mark scheme, of course. You get 1 method mark for the working I just wrote. Notice this OE, by the way, let me just point this out, is equal to or equivalent. Might be something you're unfamiliar with from the mark scheme. So that means as long as I write something that means the same, that will still give me the method mark here, for example. I'm not sure what else I could write, but if I did, and it's the same as this calculation, you get the M1 mark. Okay, let's keep hurtling through. So, nice ratio question. I remember, so my year 11s that are in my school, shout out to you, by the way. Good luck on Tuesday. I remember teaching this in year 7, so I had quite a few in year 7, and I did divide them by a given ratio, and I taught them this in 3 easy steps. The way we do a dividing by ratio question, I'm looking for these two words, is we add the two parts together. So 5 plus 3 is equal to 8. And I'm going to put that in a different colour. So you can see what number goes where essentially in our method. Then we take the total amount of centimetres, 96, and we divide by the number we just made. So the number 8. Okay, so this number here. Let me get the purple out again. We do enjoy maths. There's something very satisfying about maths. Okay. If we do 96 divided by 8, this is equal to 12. Again, if you're not happy with that, you can use the bus stop. I know everyone loves the bus stop. So 8 into 9 go 1, remainder go 3. No, 1, sorry. 8 and 16 go 2. Okay, I knew the answer would be 12. And at this point, what we do is then we just do 12 times the first part, which is 5, and then we do 12 times the second part, which is 3. 12 times 5 is 60, 12 times 3 is 36, and we have to write this in the correct order. So the bigger number goes first, because we have 5 here, and then the smaller number goes second, which goes second. So we have 60 centimetres. And 36, a check you can do in the exam is to make sure that these two numbers add up back to 96. So you can use that as a double check to make sure we get the right answers. So far, okay, I would say. Hopefully people aiming for a C have got a C pretty much by this point. And now some of the trickier questions are now coming into play. As soon as you see 4 marks on a paper 2, you know there's going to be some work involved. So A is the point minus 2, 4, and B is the point 7, 1. Find the length of AB, given your answer in simplest surd form. So this is a combination of coordinate geometry and surds, which I haven't seen in this combination, but both topics come up a lot. I generally draw a sketch here, so I'm just going to draw a sketch. Just have a rough idea of what's going on. So let me pop in the coordinates roughly where they are. So we've got minus 2 and 4, so that's up here somewhere. So this is my minus 2 and 4. And then we've got 7, 1, so 7 along and 1 up. Notice my sketch is in no way to scale, but it gives me a visualization of what's going on. And what we need to do is work out the length of this blue line that I've made. The way we do this, the standard way we do this, you may do this in a slightly different method, is I'm going to draw a right angled triangle. And the lengths that we make here are the differences between the y and the x coordinates. So notice the height here is 4, but the height here is 1. What's the difference between 1 and 4? Well, that's going to be equal to 3. Then we look at minus 2 and 7, so for the run, the x value. What's the difference between minus 2 and 7? Well, that's going to be equal to 9. You can even use the number line here. So you've got minus 2, there's minus 2, there's 7, and then think about the gap in between. Okay, that's where these numbers are coming from. And at this point, this now just becomes a Pythagoras question. So just to remind you about Pythagoras, the Pythagoras formula goes like this. So AB squared, so that's what we're looking for, is equal to this side squared plus this side squared, or the other way around. So let's continue. So AB squared, because this is what we're looking for, AB, the hypotenuse. 3 squared is 9, 9 squared is 81. So we get AB squared is equal to 90, and then we square root both sides. What's the opposite of squaring? That's going to be square rooting. So then we get AB is equal to root 90. Now you might think you're finished at this moment and you start celebrating and going, yes, I've got the answer. But we're not finished, unfortunately. With root 90 can actually simplify. So this is back to some simplifying surds. Let me do this separately over here. So we need to think what square numbers go into 90. Now our square numbers are 1, 4, 9, 16, 25. I don't think we need to go beyond this, but 36. So we're looking for the highest number here that goes in to 90. Well, 36 does not work. 25 is 75 and 100, so that doesn't work. 16 you might think works. But 16 times 5 is 80. 80 plus 16 is 96, so that's not going to work. So you keep going through the big numbers until you get to the one that we need, which is 9. 9 does go into 90. So we're going to split this surd into 9 times 10, like so. That means we can then split it like this. And then we just have to write this neatly. So the square root of 9 is equal to 3. So then we get 3 root 10, like so, for our 4 marks. As I said, if they give you 4 marks in the paper 2, they're going to get you to work for it. Again, if I'm going too fast, that's absolutely fine. Pause the video, go back, listen through my explanation again. Hopefully it'll make a bit more sense the second, third, even fourth time. Okay? This is what you need to do to get better at the paper 2, paper 4, and the paper 6. Here's the mark scheme. So you can see the answers that I've given already and where you pick up the method marks. If you put down root 90, you're going to lose a mark. So make sure you're simplifying your surds. Let's continue. So we've got question 9 here, which is a typical circle theorem question. I'm going to do part B quite differently to the mark scheme, although I understand completely where the mark scheme is coming from here. I'll do something a bit more straightforward. The first one, to find angle DCB, giving a reason for your answer. So DCB, so D to C to B, that's going to be this angle here. And the first thing that we should notice, it's part of your 6 or 7 circle theorem questions, is you see this shape. So as soon as you see a 4-sided shape, this should be your first sort of trigger, so to speak. And this shape, because it's in a circle, is called a cyclic quadrilateral. This is a phrase you simply need to know. And one of the facts about cyclic quadrilaterals is that these two angles add up to 180 degrees. So to work out the red angle, we need to do 180 minus 98. Again, I'm doing this old school. I'm working my way through. So if we do that, we'll actually work out the answer is going to be 82 degrees. And our reason is because cyclic quadrilaterals, and even though I call this cyclic quads in my lessons, I'm in the exam, so I'm going to write this properly. Now you can write, if you're old school, supplementary, but I just generally keep this very simple. Add up to, or angles, cyclic quadrilaterals, angles, we've mentioned angles specifically, opposite, not much room is there really, add up to 180 degrees. Okay, again I've shown tons of working there to get the 2 marks as well. We'll look at the mark scheme in a moment. The next question is kind of interesting. So is PBQ a tangent to the circle? Now I know what the mark scheme wants you to do, but I would approach this in a different way, which is fine, yeah? We can do or equivalent. If this is 82 degrees, then we can actually work out this angle by doing angles in a triangle, yeah? So 82 plus 57 is, okay, we just add together, so 9 and 139. We take that away from 180, so we just go through the process and hopefully we agree that it's going to be 41 degrees. Okay, so you can check that. I would double check this in the exam, so 57, 41, that's 98, that makes 100, 180. So I'm double checking every time I'm going through a question here. If this was a tangent to the circle, this should be a right angle. Okay, so QBD should be a right angle, and it isn't. So QBD is not a right angle, because if it is a tangent to the circle, it always meets the diameter at 90 degrees, and it doesn't. Yeah? I guess we're not told specifically it actually is a diameter. I kind of assumed this. So then the alternative is, if this is not acceptable, not a right angle, it'd be interesting to see what you think in the comments actually, but I would have approached it this way. The alternative is the alternate segment theorem doesn't work. So you just need to write down alternate segment theorem. Just to remind you, the alternate segment theorem is that basically this angle needs to be equal to the angle in the opposite segment. Okay, and because 56 is not equal to 57 or 82 for that matter, you know then that this can't be a tangent to the circle. But I was going to approach it this way and say QBD is not a right angle. It's actually equal to 97 degrees. But I assumed this was a diameter of the circle. This is how I went about it. But we're not given this because it doesn't go through the center. So this is why we have to refer then to the alternate segment theorem. It's good talking through these questions, because then we can see, okay, that would have been my thinking, but I can now see why this would have to be the answer, because we do not assume that this is a diameter. It's just a chord instead. Okay, let's move on. Okay, so any mention of alternate segment theorem gives you the method mark there. Okay, now we've got a simultaneous equation. So this is set up in such a way that they want you to solve this by substitution. Normally when we teach this, we want to do it by elimination. But this is set up in such a way that we want to do this by substitution. What do I mean by this? So y is equal to 3x plus 9. So what we can do is replace the y in the first equation with 3x plus 9. So what I'm going to tell the examiner here is I'm going to sub 2 into 1. So what I mean by this is I'm going to copy out the first equation, and wherever I see a y, I'm going to replace it with a 3x plus 9. Okay, giving me essentially a linear equation to solve from here. So let's go through this. So we get 2x plus, we're going to expand out the single bracket, 3 times 3x is equal to 9x, 3 times 9 is equal to 27. Okay, 9x plus 2x is equal to 11x. 27 is equal to 5. We minus 27 from both sides. So our standard algebra practice here. This cancels with this. We get 11x is equal to, well, 5 minus 27 is minus 22. And then we divide by 11. This cancels with this. X is equal to minus 2. But we're not finished. Notice we need to find the value of y. The way I would do this is I'd sub x, so the value of x here, I put this back into one of the equations. I'm going to put it into 2, it's the most convenient. So y is equal to 3 lots of minus 2. So I'm copying this equation, replacing the x with minus 2. And then we just work this out. So 3 times minus 2 is minus 6, plus the 9, and that's equal to positive 3, which gives us our answer. Okay, so you'll see the mark scheme here. Again, please do pause the video, particularly on the more difficult questions, if you're not entirely sure exactly the method I've gone through. Again, I'm going through these reasonably quickly, but I want you to try and get that pace up for when you do the real exam in, well, for some of you, this year's cohort in about 2 or 3 days' time. Be ready for the next question. This is a bit of a tricky one. Question 11. So trig, but not in the way that you expect. So the table here shows some trigonometric ratios, each correct to 3 decimal places. This is more of fashion now in the last couple of years, where they're doing non-calculator trigonometry problems. And you use the information that's given to find sine 110 degrees and tan 320 degrees. Okay, so the way I'd approach this is draw a rough sketch of the two graphs. So for sine 110 degrees, let me just draw the sine function, which you should know more or less off by heart. It goes between 1 and minus 1, and it has this wave idea, where the peak of my wave is at 90 here. The minimum point here is 270, and then it crosses at 180 and 360. So you do need to know this diagram and how it works and how it functions. So we're given two values here. We're given 70 and 40. The first thing I would notice here is I put in the value I want, which is 110. So here, 110. And I would notice that this is 20 degrees, 20 degrees away from 90. So notice there's a symmetry here of the graph that if we look at this point and this point, they're the same. Therefore, this means that sine 70 must be the same as sine 110. So essentially what I've done here is worked out that sine 110 by symmetry is equal to sine 70. And we know this from our table. We can just read this off. So we're just going to put in the number 0.940. Okay, so this is a bit more of a nuanced question with trigonometry, and you simply need to know your graphs and how they work and how they operate. This one is in some ways even trickier than the previous question. So do watch this again if you're getting stuck. So the tan graph looks like this. It's a very weird graph. So it goes off to infinity, and then comes back from minus infinity, and it goes off to infinity again. And we get this kind of repetition that goes on. So let me put in some important values. Let's use a different color. Let's use red. So we've got our asymptote here, and this is at 90. This point's at 180, so the graph of tan repeats every 180 degrees. And this is why our asymptote would be 90 plus 180, which is 270. Okay, and then this would here be 360. Okay, we can't really label the y-axis. Tan 45 is 1, for example. You should know that. Just off by heart. That's not really going to help us. Okay, so let's consider tan 320 degrees. The first thing I'm going to notice here is going to lie around about here somewhere. So let's put 320 degrees there. And then the next thing I notice is compared to this, it's essentially the same idea, isn't it? So this here, this gap here between 320 and 370 is 40. This gap is kind of equivalent to this gap here. If you take the actual graph, imagine you spin it around, essentially it's the same idea. The only difference is this makes a positive number, whereas down here, if I go all the way across, there's going to be the same number, the same distance from 0, but the negative version. Okay, now we know tan 40, we're told this in the question. We're told tan 40 is equal to 0.839. So the answer for tan 320 is going to be the same value, okay, the same gap away from 0, but it's going to be the negative version. It's going to be minus. So our answer is going to be minus 0.839. Now generally at iGCSE, I would teach this actually by using the diagrams. When you get to IB level, then we start using what's called the unit circle, the Einheitskreis in German, and then we go about it that direction instead. But I think at this level, I would still use the graph and use the symmetry of the graph to understand where these values come from. I would definitely say this is AA star territory in terms of difficulty of question. Kind of unusual. Haven't seen many questions like this recently. The two answers, you're just given the answers, there's no method mark given. Question 12 is a nice factorising question. So we want to factorise completely the following expressions. So generally the structure of these questions is the first one is a single bracket and the next one is a double bracket. Generally that's how they structure these to work your way through from easier to hard. So the first thing we notice here is all the common factors. So we need to think the number, the highest common factor of 4 and 6, that's going to be 2. The highest common factor of x squared and x is going to be x. And if you would like, you can even write this out into a long notation. Just so you can see what's going on. And that helps you to work out the common factors, yeah? So there is 1x shared, and when we talk about y, there's also 1y shared as well. And then we kind of work backwards. So we look at 2xy. What do I multiply 2xy by to get to 4x squared y? Well, 2 times 2 is 4, so I need a 2. X times what gives me x squared, that's an x. And I already have a y, so that's fine. And I do the same process here, but for the second term. So what do I multiply 2 by to get to 6? That's 3. What do I multiply x by to get to x? Well, just leave it. And what do I multiply y by to get to y squared? That will be y. So that's going to be my final answer of 2xy, open bracket, 2x minus 3y for the 2 marks. And the next one, as I indicated, this is some kind of double bracket. The reason I know this, for this particular question, even though it looks kind of weird, notice that 9 is a square number. X squared, by definition, is a square number because it has a squared in it. And 1 is also a square number. There's a minus in between, so we should be thinking the difference of 2 squares. So as soon as you see this kind of thing, you need to be thinking the difference of 2 squares. The way we do this, we think of the square roots of the numbers we just talked about. So the square root of 9 is 3, the square root of x squared is x, the square root of 1 is just 1. So this then gives us the numbers to put into our brackets. So we get 3x, because the square root of 9x squared is 3x, and we put 3x in both brackets, and the square root of 1 is 1, so we put 1 into both brackets, and because we've got a difference of 2 squares, we need a minus and a plus. Now if I was in the exam, I would actually expand out these brackets and check that I do get up here. So 3x times 3x is 9x squared, plus 3x, minus 3x, minus 1. These cancel, and I get back to what I have here. So, as you notice, my exam technique is I'm always checking what I'm doing to see I haven't made any silly mistakes as I go along. Okay, so there's the mark scheme there. Again, 1 mark question, you just get the mark for the answer. Now we get to go into some logs, which is always great fun. So let's continue. So we've got log 9 to the base x is equal to 2, and we need to work out what x is. And the way to do this is to write this out as a power statement. So you can rewrite this as x is our base. This small number is always called our base. This is always our index. So that's going to be a 2. And then it's equal to whatever this number is. So all I've done is just rewritten the log as an exponential statement, as something with a squared in. Once we do that, we can then work out our answer. So if x squared is equal to 9, then x is equal to plus or minus 3. But for logs, we're only going to take the positive answer, so that is 3. And again, you can always check this. You know, log 9 base 3, well, we have 3 squared is equal to 9. This makes sense. This one here, we're going to do a bit of simplifying logs. So the first thing is the third rule that we learn, which is the 2 that can come to the back. So this should be a log law you're familiar with. So we can write log x squared minus log 4 is equal to log 9. One of the biggest mistakes made on this question is trying to cancel the logs immediately. You're not allowed to do that. We have to simplify it, so log something is equal to log something, and at that point we can simplify. Remember, when you're subtracting logs, that's the same as dividing. So we get log x squared divided by 4 is equal to log 9. Only at this point, where you have log something equals log something, at this point you can essentially raise by a power of 10. It has the effect of cancelling, and only at this point can you then start simplifying. And from here, we're just going to a normal equation, so we times by 4 on both sides. This cancels with this, we get x squared is equal to 36, 9 times 4 is 36. We square root, and then we get x is equal to, strictly speaking, plus or minus 6, but for logs, we take the positive answer. So we get x is equal to 6. Nice log question, definitely on the harder side of the scheme of learning. So make sure you're familiar with logs. Often comes up on paper too, and it's usually a decent chunky question, 3 marks or so. it's a topic you need to know. Okay, there's 3, there's 6. Let's continue. So what do we have next? Oh, I like these questions. So we've got a proportion variation question. Again, I'm just picking out keywords when I'm answering these. As soon as I see varies, I know what kind of process I want to do. Notice we've got a few extra words here. So we've got inversely. We've also got as the square root of x. So we need to be very careful at the start with our proportionality statement. So y is proportional to, this is what this means, proportional to. Now we've got inverse, so we need to write this as 1 over. Okay, so that ticks off the inverse part. And then the square root of x. So then we put the square root of x. And now we want to write this as an equation. So the way we do that is we replace the fish symbol with an equals and replace the 1 with a k. So we get y equals to k over root x. So that's our equation. And now to find the constant, we now use the last bit of information, which is substitute the values in. So when x is equal to 25, y is equal to 6, so 6 is equal to k over root 25. That means that 6 is equal to k, well, square root of 25 is 5. And now to work out what k is, we times by 5 on both sides. That gives us 6 times 5 is 30. So k is equal to 30. And we have to bring this all together now. So when we write our equation, we replace the k with 30 to get y equals 30 over root x. And generally on these questions, they get you to use this equation to do something else afterwards. So it's one of the first few questions I've seen where they just get you to do the equation and that's it. Okay, nice question, 2 marks, fairly straightforward. Now we're on to probably the topic I like the least on the whole iGCSE course. And it's the very last question. So I know if I was sitting this paper, I would be groaning and go, oh no, the Venn diagram question didn't come up early, it came up late. This is where I'd start groaning slightly, but there we are. Right, so on the Venn diagram, we need to shade the set in A and B and not C. So before I even start, I would write this out in normal notation. So A and B and not C. Okay, another way of thinking about this is the intersection of A and B and not C. Well, let's imagine we had the intersection of all of them, yeah? So the intersection of A and B and C. Well, that would be the middle part there, okay? So that would be the middle part. However, we want the intersection of A and B and not C. So which parts are not C? Well, this is not C. But the part that we had before is part of C. So we need to rub that part out. Okay, so that gives us then our answer of A and B and not C. We considered A and B and C, and then we thought, what's not in C? And what we realized there is we can't keep this part because it's in C, but this part here is not in C, but it's still in A and B as well. Okay, so that's for 1 mark, and it's quite, I don't know, quite mean to give you just for 1 mark, you know, a complicated question like this. So now we need to use set notation to describe the shaded region. Okay, so the way I go about this is, I would think about what this is. So I'm looking at the part that's not shaded in. Kind of looking at this kind of backwards. So I'm thinking of P or Q. Remember, this means the union, it means P or Q. If I was to shade this in, this is P or Q. Okay, I'm not considering R, I'm just shading in what's P or Q. So I've shaded that in, and that's P or Q, but I don't want that. Okay, in fact, I want completely the opposite of that. So what I do then is I just put in, well, P or Q, but not that. And this is what this dash means, it's not that. So we shade that out, because that's not what we want. But now we need to include in the r part. But we have to be careful with our notation here. Okay, if I was to put u, r, I would then need to shade in these parts, okay, because it's still all r. However, we don't want these parts shaded in, so we need to use the intersection part instead. So we actually want to write in instead and r. Okay, so we want p or q. That was the bit I shaded in initially, but we don't want that at all. So that's why I put the dash in there, so not that. But then we need to include in the part of r that's not in p and q, and we do that by using the intersection and not the union part. So our final answer will be p or q, but not that, and r. And there might be another equivalent way of writing that. That's perfectly possible, but I think that's the easiest way to explain this pretty difficult set notation question. Okay, so there are the two answers, okay, the ones that I've just done on the board. So that is the end of this walkthrough. So I've gone through all 15 questions here. I've gone a little bit on the quicker side compared to some of the other videos. Again, please write down in the comments below if you like that, or you've got any questions about this particular paper. Again, this is a kind of bonus for you, so you're ready for your exam on Tuesday, so you can show what you know mathematically. Right, I bid you farewell. Again, please like and subscribe. It goes a long way to helping the channel, and it gives me an idea that you want more paper twos. I can keep doing paper twos. That is absolutely fine. All right, bye-bye for now.